In this video, I'd like to talk about how to solve quadratic equations by taking square roots. And in this video, or in the next couple videos, I'm going to go through 6 different problems. The first 3 will be from the intro exercise on the Khan Academy, and the last 3 will be from the regular exercise. And one thing to notice about all of these problems is that you're going to have some squared term, maybe plus a number equal to some other number. But you're not going to have an x term. So if you had something like x squared plus 2x plus 5 equals 10, let's say, this is not going to be able to be solved from this method. Because in general, this method, we're going to solve for the square term, so this term in this case, and then square root both sides. But notice if we do that here, so I'm just going to move all these to the other side, you get x squared is equal to, let's see, if you take away 5, this just becomes 5. And you'd have to subtract 2x, so you get minus 2x plus 5. But when I take the square root of each side, by the way, you got to put plus or minus, this doesn't really tell us much at all. In fact, I would argue this is much more complicated now. Because square roots, when you have sums or differences, are notoriously very difficult to simplify or manipulate algebraically. So since we still have x on both sides of the equation, this is not solvable in this form. We need to come up with a different way to approach this. And we'll talk about this in a later video when we complete the square. But for now, we're going to look at equations without this x term. So let me just erase all that. And I should mention, sometimes it's not just an x squared. Sometimes it's a whole expression squared, like x plus 3 squared minus 2 equals 15. This is solvable as well because when you solve it for the square term, you can just take a square root of every side. And as long as you don't have x on both sides when you're taking the square root, you can solve it that way. So that's the more difficult exercise. But for now, we'll just look at when we just have an x squared. So let me just rewrite this. X squared plus 7 is 43. And the strategy for these is straightforward. You want to solve for the squared term, and then just take a square root of each side. So let's subtract 7 on each side. So you get x squared is 36. And from here, what number squared gives us 36? Well, there's actually 2 different numbers here. Since positive 6 works, 6 times 6 is 36, but negative 6 works as well, since a negative times a negative is a positive. So this would also give you 36 when you square it. So when you take a square root of each side, so let's say we're taking a square root of each side here, you have to rewrite this as plus or minus the square root of 36 to account for the fact that there are 2 solutions. Now, technically, there is a subtle step involved. The square root of x squared is actually the absolute value of x, equals 6. And when you solve absolute value equations, you do have a positive and a negative solution. So that's another way to think about it. And why is this equal to the absolute value of x? Well, think about it. Any number you put in here, negative or positive, will come out a positive number. Because when you square something, positive or negative, it always becomes positive. So that's why it's always going to be equal to a positive number. Like if I just said this is equal to x, when I put in minus 3 here, and I square it, I would get 9, and then square rooting it, I would get positive 3. So I wouldn't get back exactly what I put in, I would get back the opposite, or the positive version of that. So that's why you need the absolute value bars. And if you're familiar with solving absolute value equations, that's where you get the plus or minus from, because there's always 2 solutions to this. So anyways, my main point with this is that when you take a square root, you just need to put plus or minus in front of the square root to account for the fact that there are 2 solutions here. So in this case, the lesser value of x would be minus 6, and the larger one would be positive 6. So let's move on to another one.